Welcome back to Learn with Because. Today we are driving into the AWS Lambda and API Gateway, two core services that make serverless API development easier and more scalable. Think of the AWS Lambda as a chef in a restaurant. Whenever an order comes in, the chef prepares the dish on demand. No need to keep the stove running 24 by 7. Similarly, Lambda executes code only when triggered, making it cost effective and scalable. But here's the catch. Our chef needs a waiter to take the order from customers and bring them back. So that's where the API gateway comes in. It acts as a middleman that receives requests from the users and delivers them to Lambda. But why we use API gateway when Lambda already has a functional URL? Let's find out. So AWS Lambda is a serverless compute service that allows you to run code without worrying about infrastructure. Imagine a vending machine. It only operates when someone presses a button. Similarly, Lambda runs your function only when it is triggered, meaning you don't have to keep a server running 24 by 7 the whole month and the whole year. So Lambda is event-driven, meaning it activates only when required. It automatically scales. So if one person triggers it, great. If million people do, it scales accordingly. No manual intervention is needed. Another great aspect is its support for multiple runtimes, including Python, Node.js, and .NET, making it flexible for different programming needs. To put this into the real world analogy, imagine you own a small bakery. Instead of baking hundreds of loaves in advance, possibly wasting them to bake only when a customer orders, ensuring efficiency and no unnecessary cost. That's exactly how AWS Lambda optimizes the compute resources. So before jumping into the comparison between the functional URL and the need of the functional URL and the API gateway, we need to know what is API gateway. So this is a short explanation for the API gateway and the key points to take away. So API gateway is likely the main entrance to your AWS Lambda function. Without it, your function is like a restaurant without a menu or waiters. Customers would not know how to place an order. So a great way to visualize this by thinking of the API gateway as an airport terminal. Passengers, that is the incoming API requests, arrive and the terminal directs them to the correct flights, that is the Lambda functions. The terminal also manages security, this is the authentication, and organizes the boarding process, that is the rate limiting and the request routing. So without an airport terminal, passengers would not know where to go, just like how API Gateway ensures requests reach the right function efficiently. So the comparison is the features that let's compare the Lambda function URLs and the API gateway side by side. So you can see the table that I have created here for a simple. And the Lambda function URLs offers minimal authentication, relying only on IAM policies or remaining open to the public access. In contrast, API Gateway provides full authentication support, including the IAM, JWT, API keys, and Cognito, making it much safer for external users. Another key difference is routing. Lambda function URLs are limited to just one function per URL, while API Gateway allows you to handle multiple endpoints with different HTTP methods, giving you much more control over how your API behaves. So security is another critical area. Lambda function URLs have very basic security, whereas the API Gateway includes built-in protection against the DDoS attack, rate limiting, and AWS WAF integration. Lastly, the common domain support is a game changer. Functional URLs require additional workloads to use custom domain, while API Gateway natively supports it, making it much more convenient for branding and production use. To put this into analogy, think of the Lambda functional URLs as a bicycle lane. It's good for simple, single-purpose travel. Meanwhile, API Gateway is a highway, handling multiple lanes, tolls, and exits, allowing you for much more organized, secure, and scalable system. So, what are the key takeaways? So, before we start the video, we'll have to know about what are the key takeaways. So, Functional URLs are great for quick internal projects, but they lack security and scalable features. If you are planning to expose an API to multiple users, where it will be web app and mobile apps and anywhere webhooks or something like that, so always choose API gateway to ensure the scalability and the security. So up next, we'll deploy a real serverless API step by step using Lambda function and the API gateway. So make sure you like, subscribe, and turn on the notifications so you don't miss it.
Okay, so let's have an hands-on experience on the creating the Lambda. So here we are going to create a Lambda and connect the Lambda to the API gateway. So first we need to have a Lambda function to connect to API gateway. So I'm putting the Lambda function name as demo Lambda. So I'm going to select the Node.js 22 point some versions, and for the sake of simplicity, and the execution role that we are putting is to create new role with basic Lambda permissions. We are not using the existing role. If you have an existing role that you are using regularly, then use that role, but there's a chance to get some kind of issues with cloud logs that I have seen in the Stack Overflow. So please be aware of that. And here we are going to enable the functional URL. Why? Because we just need to test the public accessibility of the function. So we're going to put as none, because this is for simplest we are having a demo. And the enable VPC part, if you have VPC, default VPC, and you have any elastic cache that needs to be connected through the Lambda function, then you need to enable the VPC, because elastic cache can be connected only through the VPC. So currently in our scenario we don't have any kind of elastic cache, so we don't want the VPC here. If you have any kind of tags also, then you can click enable tags and add those tags there. So this may take like 5 to 10 seconds to create a new Lambda function. So the Lambda functions has been created, so we can see the code here as it just returns the hello world. So we can check the public accessibility of this Lambda function by clicking this URL. So we can see the hello from Lambda is coming, so the Lambda function is working. So yeah, now let's have our API gateway attached to this Lambda function in the next section. Now let's go and see inside the API gateway how it looks like. So we are so curious, right? So this is our API gateway and it looks like this. And if you go to roots, then you can see there's a Lambda and there's an any, and this has no authorizer currently attached to it. And if you see the authorization, and there is no authorization attached to it because we haven't attached. And there's integration, this API gateway is actually integrated to Lambda, that's why here we are seeing it's Lambda, AWS Lambda here, and we are seeing that's AWS Lambda name that has been integrated with that. And you can see the timeout and other details here. And of course we have not implemented, and the stages, you can see the default stage that was there while creating, and we have this default invocation URL here. And if you have any kind of variable staging variables, you can add it here, feel free to do that. And let's attach a authorization to this API gateway. So what kind of authorization that we are going to attach is a Lambda based authorization we are going to attach. So if you go to functions here, I have already created an authorizer Lambda function. It is a very simple Lambda function. And if you can see, this Lambda function is looks like this, because this token here, this is a token that needs to be sent from the client, and this token is validated. If the token does not equal to this one, then we are putting is authorized false. If does equals this one, then we are putting is authorized true, and the context is the user. It is the authorized user object that you can have. So this is a very simple authorization technique that we are going to use, this hard-coded way. How the production level will look like: you have this token, you need to have here the find one user or something like that, your identity server, to see whether that token validate against the user. If you are going to use the JWT, or if you are going to use the Firebase token or something like that, then you will have set up written here to validate that, so that your API gateway will trigger this Lambda function, and the Lambda function will give the response like this, and the next part will have your original Lambda function will be triggered with this authorized context in it. So I have created this simple Lambda function, okay, and we are going to attach this simple Lambda function with the with our API gateway. So here you can see our API gateway is here, and we are going to go to functions and demo Lambda, and click on this API gateway and open this API gateway, and here we are getting Lambda hello from Lambda, so it's working, and it's for sure it's working. I just want to make sure it's working. And here the authorization part, create and attach an authorization. We have JSON web tokens based kind of authorization, we have Lambda based authorization. I'm going to put Lambda based authorization right now, and here I'm going to choose my authorizer here, and we're going to put an authorizer name. I'm going to put my Lambda auth. I'm going to put, because you can write your custom logic there, so it's very simple thing. If we want to cache the authorizer, we can cache the authorizer, because you can cache up to 3600 seconds. But this is the field that we are going to validate. So if you see that this is the field, and here in the functions in the authorizer we are actually validating in the code. If you can see, just a second, you can see that we are actually validating against the authorization in the headers. So this is the authorization in the header that we are going to use. So I'm going to create and attach, and this Lambda is attached here. So if I come here and so refresh, now it's not working because we don't have that authorizer. So our message has come as that is coming as unauthorized, because we have not sent the header on the URL. So I'm going to use the Thunder client just to check on this one. So I'm opening the Thunder client here, and I'm going to click, let's let it load for a second. Thunder client, yeah, now Thunder client has been loaded. So I'm going to click on new request, and I'm going to paste that URL and going to trigger same unauthorized coming. I'm going to auth, I'm going to bearer, and the token that we have put here is inside the BI is my secret token. This is a custom token that if you have a mobile app or a web app, this is the token that needs to be sent from the client side, since we are having a little demo here. So I'm going to put the hard-coded client. So I'm going to trigger it now, and it will say hello from Lambda. So we have implemented some kind of authorization to our API gateway endpoint right now. Next thing that we are going to see is how we are going to implement the caching part on that API gateway. If you want the advanced level caching in the API gateway, then we shouldn't choose the HTTP method of this API gateway creation. So here, when you select the API gateway creation, you don't need to choose this method, but this method does not contain any kind of advanced caching options and flexibilities available. So if you are focusing on putting caching in the API gateway, you need to select this REST API. So when you select the REST API, and I'm going to create the REST API, I'm going to say it as REST something, and I'm going to provide a stage called dev or develop something, and I'm going to create a new REST API, because we need to have flexibility in handling the caches. So now we can see that it's there, and currently we have not added any authorizer to this REST API, so it's working fine. And I will copy this URL, and we can test in the uh, this here also. And if you see that average response time is like 120 from 80 to 200 kind of range. And we're going to open this API gateway here, and let's go to APIs, and let's refresh, and let's see, we have a REST API here. So let's go inside the REST API, and you can see if you click on any, you have a lot of things here. So in HTTP 1 there was a lesser, and here we have a lot of things because here we have more flexibility to integrate caching and throttling and burst, this kind of things we have. You can see here this is the Lambda function, and it's attached to our ARN, so it looks fine. And if you go staging, and you can see there are a lot of options in the staging. This is the new staging that we have created, and inside the staging you can see the cache cluster is inactive, and the burst is 5000 by default because it's an account level burst that's happening. And you can edit on this one, and you can see provision API caching, and the storage that is going to use the API is 0.5 GB. You can have multiple options, but I'm going to see the minimum. You can encrypt the cache data also if needed, and the time to leave is 300 seconds. And you can also already have like method level caching, because this cache for all the get methods in the stage, because we have a lambda function of any, so we don't, there's no problem on that. We can enable the throttling also if you want, and you can have the WAF for DDoS attacks and all the things here. So yeah, so let's click on continue, and I'm going to save the changes, review and save the changes. So the cache cluster is being created right now, and let me refresh the page. Let's see whether we have cache clusters being created. Let's pause the video, and I will come back once the cache cluster is created. Now you can see our cache cluster has been provisioned and it is active right now. And let's test that out a little bit, and let's hit the endpoint, and it's returning the values here from the demo. And I think it's coming from the cache, it's not coming from the lambda. So how to make sure that it's coming from the cache and not from the lambda? Let's go to this monitoring part and view applications. Let it load for some time. Yeah, so going to view CloudWatch logs. So what we are expecting here to see is whenever we hit the API gateway, it should not trigger the lambda function because the API gateway has caching and it returning the hello world from the cached data. So we can see it start trailing, and we can see we are waiting here for the logs. To test it out a little bit, let's open this code and this function URL, and we can see this hello lambda here and is coming, and we can see we need to wait a little bit to see we can see the logs are coming. So the lambda logs are coming, so it's working actually. Whenever the request hits the lambda, the logs are coming. So let's clear this, and let's hit from the API gateway. This is the API gateway URL and the demo lambda, and hit it from there. And we can see we are getting responses, 3 or 4 responses, and here we can see there are no logs coming in the lambda because the API gateway is not hitting the lambda, it's hitting the cache and it's returning the data from the cache. That's why here we are not having any kind of logs coming to the lambda function. And if you are like just like learning, then delete all the API gateways because it may cost you little price per hour or something, and per input output operations. So if you are learning, just delete the unused resources. So this is how we can integrate the caching and the authorizer to a lambda function, and we'll see in next video. If you like, please subscribe and comment, and click the bell icon for more videos. And thank you. We'll see you in the next video.